Hello, my students. How are you? Hope you are doing fine. Yesterday, we discussed how we can use matrices to solve any problem relating to equality of two matrices and how to find inverse of matrix of 2 by 2 matrix. Today, we are going to look at how to apply matrix in solving simultaneous equation. So let's look at the objective. Let's go learning. Today we are looking at apply matrix method in solving simultaneous equation. I believe you can write your notes now. So that is what we are doing today. So we are going to look at matrix method of solving simultaneous equation. So how do we solve using simultaneous equation? Now let's look at this example. We are given that use matrix method to solve the simultaneous equation 2x plus y equals to 10 and 4x minus 2y equals to 4. Now let's look at this. If you can see now. All right. The first thing we need to look at is to extract the coefficients of x and y. Don't forget what we are looking for. We are looking for the unknown. We want to find the unknown. So we extract the coefficients of x and y. So you write the equation in matrix form. Let's write it in matrix form. We have in matrix form. I'm not going to put x again. I have 2. The coefficient of x is 2. The coefficient of y here is 1. The coefficient of x here is 4. The coefficient of y here is minus 2. And I'm looking for the unknown x and y equals to 10 and 4. So this is how to write in matrix form. So let's take this one as the first equation. We write it in matrix form. Then the next thing, we say let A equals to this matrix 2, 1, 4 minus 2. Then we can say let x, capital letter X, equals to s and y. Let B equals to, what do we have as equation? 10 and 4. So after that, the equation 1, I said we should take this one as equation 1. So this become, if I say this is A, this is X, and this is what? B. So that means I'm going to have AX equals to B. Do you see that? So let me take that one as equation 2. Now, after that, from here I have AX equals to B. On both sides, I'll multiply both sides by the inverse of A. One thing I did not remember to tell you yesterday was when we have A times A inverse is giving us an identity. So you can please go through your textbook. You will see, you discover that when you multiply A and A inverse, it's going to give you the identity. And this identity is neutral. Don't forget, what do we mean by identity? 1, 0, 0, 1. That's our identity. So what I will do is to multiply both sides. Multiply both sides of equation 2 by A inverse. So if I multiply both sides, that is this side and this side, by A inverse, I will have A multiplied by A inverse with X equals to B multiplied by A inverse. Do you see that? So I can write my A before B because A comes in alphabet. So I have A inverse X equals to A inverse B. Anyhow, you get that now. So from here, A multiplied by A inverse is giving me identity. So and anything I multiply, so you note that A multiplied by A inverse is what? Is an identity. So any set, any matrix, sorry, you multiply by an identity, we give you back that matrix. So you can try it. Just take 1 0 0 1, multiply it by a matrix. You see that you get that matrix back. So here I'm left with x because it's going to give him x back here. So I'm left with x equals to A inverse B. So I'm going to find the inverse of A and I'll multiply it by B. Don't forget, what is our notation? Our notation, x is x and y that I'm looking for. And A inverse, I'll find the inverse of A. Then I'll multiply it with what? B. My B is 10 and 4. So we have, before we can find the inverse, we did inverse yesterday. So we need to take the determinants. Take the determinants to find the inverse. So let's find the inverse of A. The first thing we need to take the determinant of A. How do we get the determinant of A? You know, this is A. This is A. To find the determinant of A, I have 2 times minus 2 minus 1 times 4. Don't forget, leading diagonal minus what? The second diagonal. So that's the determinant of A. So A inverse, I'm looking for A inverse. The A inverse now will now be, so sorry about that, I went to check something. Now I have A inverse. How do we get A inverse? That's 1 all over the determinant. Determinant, what do I have here as determinant? Is equals to, that's minus 4, and that is minus 8. So the determinant is minus 8. Minus 8. Then, what again? I will interchange what I have in my leading diagonal. What do I have in leading diagonal? I have 2 and minus 2. So I'm interchanging that. So this will be minus 2, and this will become 2. I will change the sign in the second diagonal. This will be minus 4, minus 1. So this is A inverse. So let me multiply that. My A inverse will now be this times this. That is minus 1 over 8 times minus 2. So that's going to give me 2 over, minus we cancel minus. Let me work it out for you. Minus 1 over 8 times minus 2. You know, 2 here 1, 2 here 4. So minus times minus is plus. So I have 1 all over 4. Do you get that now? So I have 1 all over 4. Then minus 1 over 8 times minus 1. That will be 1 all over 8. Because minus times minus is plus. Are you getting it? Then the next one, minus 1 all over 8 times 4. 4 in 8 is 2. So I have minus 4 all over minus 8. So that will give me 1 all over 2. Are you getting it? 1 all over 2. Then the next one, minus 1 all over 8 times 2. That will still give me minus 1 all over 4. Because I have plus 2 here. So that's giving me negative 1 over 4. So the next thing I'm going to look at is, I know my inverse now. My inverse is this. So, and I'm looking for x equals to A inverse B. So what will I do? I will take my x equals to, what is my A inverse? I'll write what I have. 1 all over 4, 1 all over 8, 1 all over 2, minus 1 all over 4, times, what is my B? Don't forget, my B is 10 and 4. 10, 4. So I'll multiply. This times this, that's 10 all over 4. Plus this times this, that's 4 all over 8. Are we following? So the next one, this times this, that's 10 all over 2. Plus this times this, you know this is minus. So this will turn to minus 4 all over 4. So I'll cut the fraction. Let's work it out. The fraction now becomes x is what? This 4 all over 10 all over 4 will give you what? 10 all over 4 will give me 5 all over 2 plus 1 all over 2. If I cut it, Then this will give me 5 minus 1. So the next thing, I'm going to solve this fraction here. 5 over 2 plus half. What's that giving me? 5 over 2 plus half. So the LCM is 2. I have 5 plus what? 2 into 1 times 1. That's 6 all over 2. 6 all over 2 will give me 3. So this is going to give me 3. Then 5 minus 1, that will give me 4. So at the end of the day, we know that our x, what is my x? My x is x and y equals to 3 and 4. So therefore, my x is equals to 3 and my y is what? Is equals to 4. So that is how to solve matrices using how to solve simultaneous equation using matrices. Do you understand that? Thank you.